Hello, everyone. Welcome to this Hackages webinar. My name is Eliran Natan, and I'm going to talk today about domain-driven design with CQRS and event sourcing. So please feel free to send your questions and remarks during the presentation, and I will do my best to refer. I already see that we have some activity here, or a lot. Hello, everyone. Yeah, very happy to see you all. So let's just start with the context. I will share the slides with you. Yeah, okay. So I want to start, first of all, to talk about the context of the problem that we are facing. So developing a large-scale enterprise software has its challenges. One of the biggest challenges is closing the gap between developers and domain experts. Because usually when we are talking about domains that are complicated, such as healthcare or cybersecurity or banking, we developers tend to not fully understand and grasp the complexity of such domains. And then we tend to invent our own private language to describe um, such such complicated stuff. Now, that also in turn creates complicated code and problems with the performance and scalability. It also creates some sort of a discommunication or translation overhead with domain experts. And so this is exactly where domain-driven design comes into play, because it aims to close this gap. It enforces some strict rules on your code that makes it more aligned with the domain that you are working with. Now, event sourcing and CQRS are often mentioned when speaking about domain-driven design, but they are actually not part of it. So in this session, we will first understand what is CQRS, what is event sourcing, and we will see how they leverage domain-driven design. Yeah, so I want to start off with the problem. So let's take an example. We start with a social network example. And so our domain is basically a social network. Now, you would expect from a social network to have certain basic functionalities that you want to support. So stuff like creating a user, or publishing a post, or sharing a specific post by a specific user, or a user that want to be friends with another user. Now, those are all very basic examples, and any platform would be useless if you cannot query it. So you would also expect queries about users, such as get all users that share the specific post. Now, okay, so how could we approach such a design? Well, the most straightforward way would be to use the CRUD architecture, now, or pattern, if you want to call it that way. So CRUD is for create, read, update, and delete. And what it basically means is that I'm creating a very basic entity of a user, and this entity is filled with all sorts of fields that describe that user ID, maybe a list of posts that the user has created, a list of posts that the user has shared, and a list of friends that the user have. Now, I'm storing that structure in the database, and then whenever I want to create a user, that becomes very easy. Whenever I want to publish a post, then we just add the post ID to the post list. Whenever we want to share a post, then we add the post ID to the shared post list. And whenever someone becomes friends with, then we just add the ID to the friends IDs. So the first try is to use the CRUD architecture, which is basically a pattern that in which we just save structures into the database. So if we want to create a user or publish a post or share a post or make friends with, then we just fetch the corresponding user from the database, adjust the structure, and then save it back in the database. Now, when we want to answer to some sort of query, then we have to go through some translation layer. Now, you would almost have to go through some calculations before you can fetch an answer. So in this example, we would probably want to retrieve all the users that we have in the database and then iterate each and one of them, calculating whether this user shared this specific post, and then pack the result and send it back to the client. Now, this is a very simple query, but of course you can think about very complicated one. Yeah. Now, let's see how things get wrong, because, well, for some cases, this kind of pattern will be enough. It's pretty reliable, it's very fast to develop, and it can give you the correct results when the domain is simple, when the queries are simple, and when the data is not so big. The problem starts when you want to talk about scalability and performance. When you want to handle big data or try to resolve complicated queries that we often have to resolve when we are talking about complicated domains. So the problem here, as you can see in this toy example, is that you load into memory an entire data structures that can be potentially very big, and then you run some complicated algorithms on that structure, and those algorithms can be very complicated as well. So we could always try to resolve such case by shifting the translation layer to somewhere else. For example, here we are preparing the data before we save it into the database in a way that we could answer queries faster. So in this example, we create a mapping between posts and users, between posts to users that share this post. So whenever we are asked about the user who shared this post, we just fetch that mapping from the database and send the results. Now, that makes sense to do, especially when we are talking about social networks, because well, if you think about it, we tend to read much more than we tend to write. If you think about how many times you scroll down your Facebook page versus the amount of time that you publish a post. So it makes sense to have faster reads instead of have fast writes. But that doesn't really solve our problem entirely, because while you could always get this, can always get introduced to some queries or some combination of queries that can be very, let's say, deadly to your performances. For example, if I want to search posts by text, which is a very common functionality in social networks, or if I want to, for example, get the most popular user, imagine that your users can be mapped into some relations graph, and you want to find the most connected user, which is also a very popular functionality when we talk about social networks. Now, to support those kind of queries at the same time, I will have to use a specific database. Now, to support search text in a scalable way on big data, you would probably want to use Elasticsearch or something similar, something that is text oriented. But to support something like graph queries, you would probably want some database that is graph oriented, like Neo4j, for example. But the fact that you have only one data model and only one single underlying technology is limiting you. So you have to compromise on the scalability and performance of one of your queries. You would always have to do this compromising. So this is where the problems, I think that the problem starts from the fact that we are trying to write to and read from the same data model and the same underlying technology. So we always get these dependencies and trade-offs between reading and writing. So we start our solution from here. But before I continue to introduce the solution, I want to ask you, what do you think that we should do in such a case? Or if you can describe the solution that pops into your mind in just a couple of words, or even if you have questions about what we talked about so far, I would love to answer that. So let's see our chat again. Okay. Okay, I get all sorts of interesting questions. I can say that you're very creative. Yeah, I hear about events. I read about fancy databases like DynamoDB. I hear about DTOs. Okay, so I got all sorts kind of answers, and of course that you could always choose a very sophisticated database to help you with having faster queries or doing stuff without loading a lot of data into memory. But please keep in mind that this is by itself a translation layer, right? So your translation layer goes into the database, and that can become slower and slower when you are introduced with bigger data. Now, and you can always have a very sophisticated translation layer, but that won't save you from being able to support a scalable searching of text while you want to run queries on graphs, for example. So this is where CQRS comes into our minds. CQRS is a solution that implies that you can and should, when necessary, split your data model into two. Now, the first part is the write model. This is where your state of the application gets changed. And the other side is the read model, from which you answer queries. So the write model, it can be interacted only with commands. Commands are expressing the intention to change the state of the system. Commands will never return anything, and they do not have to be accepted, of course. The only way to interact with the read model is with queries. Queries will always respond, but they will never change the state of the application, because asking something shouldn't change the answer. Now, as you can see, you would always have to synchronize the write model with the read model. so your queries will reflect the right state of the application. Now, what do we gain when we split our data model in that way? We gain independence and freedom. Now we can model our right model the way we feel like, and model our read model in a way that is the most suitable for answering the queries that we want to answer. So we break the trade-off by splitting the database. Now, CQRS does not imply that you have to split the database itself. You could only split the data models. But here I show the solution of splitting the data stores because I think it gives you much more freedom and power, because then you can use different technologies and so on, which is a very common thing to do. All right. Now, you could always leverage the microservice architecture to have multiply read models. As a matter of fact, how many that you need, each is equipped to handle specific set of queries. Each has its own type of technology or data store that he wishes to use. So in this example, I'm using MongoDB to support my write model, which is a document-based database, and an Elasticsearch database to support one read model. And then I could get a very fast text search. Whereas my second read model is using Neo4j as the technology, and then I could support graph queries. So I keep in sync those two read models, or how many that I need with my write model. So one thing that you cannot skip when you're talking about CQRS, and this is, you could find it anywhere. Whenever we speak about CQRS, you will always be introduced to something that is called eventual consistency. Now, I think that this is a very fundamental, it's a challenge to understand and to keep in mind when you develop your platform. So I want to focus on that. So it's taking a considerable amount of time to synchronize your write model with the rest of your read models. Not only that, also that some of your read models will not be updated in the same time that other read models would be updated. So that makes you think that, well, okay, my read model is not updated, and so after each write, queries will return false information for some time. So this is what we call the eventual consistency. We call it eventual consistency because we know that at some point after changing the state of the application will return to be consistent again. So this eventually it will be consistent again. So, well, it seems kind of madness to create a platform that once you write into it, then your queries immediately returns false information. So why we are doing that? So actually, when you think about it, it's not such a big disaster, because most of the platforms that you're using today are eventual consistent. Think about banks or domain propagation, about emails and any social network that you know. When you have when you're initiating a bank transaction, then they tell you it will take up to 3 days to complete the transaction. Why is that? It's because they don't really know when it will happen. The same with a domain propagation. When you buy a domain, you have to wait 24 hours for it to be updated in all servers. This is some kind of eventual consistency. Now, this is all a very small thing of something that is called the CAP theorem. Now, CAP theorem says a lot of things, but I will narrow it down to our issue. The CAP theorem basically states that there is no system anywhere that can be both available and consistent all the time. So if you want your system to be available for querying all the time, you cannot endure downtimes, then you must accept the fact that for some time, immediately after writing into the application, that your queries will not return the correct, the most up-to-date information. And if you cannot endure this type of consistency, if you cannot endure inconsistencies, then you must accept downtimes, which mean that to some extent your application will not be available for querying, and that's what we call, well, it's more obvious when you talk about real-time systems, when decision making is crucial, and no answer is better than a wrong answer. But it's not the case in most social networks, right? It doesn't matter if you liked my cat 5 minutes ago or now, right? Okay. So one serious consideration, and I think that sums up the eventual consistency issue, is that it's really important, and that's the job of the architect or the developer. It's really important to consider whether your feature can endure eventual consistency. So you shouldn't use CQRS to implement all your platform. You can definitely, and that's perfectly fine, to select features that can be implemented with CQRS and other features that should have strong consistency models. And I would say that it's kind of suspicious if you decide to use CQRS for the entire app. I wouldn't recommend that. So it's really up to you to decide when you can use it, and where the domain is complicated enough, when data is big enough, and when you cannot endure you can endure inconsistencies. So I hope that that's making sense, and I would love to hear some questions or comments before we go on our next stage. Well, Stefan asks if this model implies that when a user writes, he doesn't get instant response of what was updated, right? This is true. When you write something, you won't be able to get an instant response because it takes time to update your reads models. That's correct. Introducing a consistency issue, as well as that what you write may not be updated on the read time. That's true. That is called eventual consistency. Yeah, that's great. That's a great question. I get a question if we have anything to say about the time in which the system is not consistent. So this inconsistency time it's called inconsistency window, and in that stage, well, if you want to minimize it, of course, that you can just make your synchronization process much faster, or to optimize it. But it will never be perfect. And some front ends, and that's more on the front end side, can fake strong consistency. And I'm as a front end developer did it many times by let's say, well, let's take a Facebook example, for example. Okay, if you like a post and you immediately see that you are the liker of this post, then it's fake consistency, because the system cannot just immediately say that you like that post, but they show it to you on the UI. You get an immediate response from the UI. So UIs can fake strong consistency with an optimal mindset that says, okay, it probably went through. The command probably succeed. So, but and sometimes you see that it didn't, and even though you like the post, suddenly if you refresh the page, you see that you're not. So this is the only trick that I know to uh, at least avoid showing that you're not consistent all the time. And as Stefan writes, most modern front-end tools handle it nicely. So yes and no. Okay, I have to continue because we are very short in time. Let's continue with talking about the domain model. So you're mostly here not to hear about patterns, software patterns, but to hear about domain-driven design. And this is, I think that's the most important slide in the presentation, because it shows the link between a domain-driven design and CQRS, and or why CQRS is even connected to domain-driven design. So when we splitted the write model from the read model, we gained performance and scalability. But that's not only it. Actually, there is a much deeper impact on your system when you're doing that. When you do that, then your write model is completely independent and free, and you can use that freedom to model the write model in the most accurate way, in the way that reflects your domain the best. Um, and that wasn't possible if you had only if you had the same model for writing and reading, because then you would have to consider trade-offs and performance and creating artificial structures that don't have any connection or real connection with the domain that you're working on. We use the example of the mapping that maps between users and the post, between the post and the users that shared it. This is some artificial structure that is not cannot really do not have a real representation in the world. So this is where domain-driven design comes into play, because now we can use domain-driven design, which is basically a bunch of great patterns that helps you model your write model in the best way that reflects your domain. Now, do not tempt, and I would say that that's a bold statement, but I would say do not tempt to use domain-driven design to model your read models. You want to keep the read models as efficient as possible to answer specific queries that you want to answer, and you want to keep your write model modeled according or reflecting the domain as much as possible. And that's only possible if you're using CQRS. If you're using the CRUD or any other such pattern, then it's very hard to do domain-driven design, or at least the proper one. So now that's one of the hardest part, and maybe the hardest part in domain-driven design is to understand your model in a way that you can model your entities in the correct way. So it's I gotta say that it's amazing when you do it right, but it's very hard to get into the right structure, because you need to have the proper experience. You need to know your domain in the most intimate way, and you need to understand what is the purpose of your system in that domain. So you need to understand a lot, and you need to do some research, and you need to talk with domain experts a lot in order to figure it out right. But let's let's do an example with our social network. So in this example, we would start by introducing the user entity. So how do I even figure out which entities I want to talk about? Well, just think about the real things that you have, the real entities or the real concepts that you have in your domain. Don't start to think about abstract or things or structures that do not exist there. Don't think about technology or how you implement stuff. Think about domain and in some way switch your hat to be a domain expert. So the first entity and the most natural entity that the social networks implement is a user. Now, a user have some sort of fields that describe this user, like ID, a user profile, a user wall, and a list of friends. It also have a list of method with which you can do stuff. So user can publish a post, user can share a post, and user can become friends with someone else. Now, derived from this entity comes other entities. We're using the user profile entity, so we better add it to our plan. And the user profile have properties such as the age of the user. Now, that's an important thing. Um, I'm using the type of the field age is age. It's not it's not number, and that's I think that's one of the most fundamental principles of domain-driven design. The As you can see in the bottom of this plan, is that the age is basically a number. But why am I using or emphasizing the type age and not just using primitives like number? We want to keep our distance from using primitives when we talk about domain-driven design. We don't want to use numbers or strings or such things. Because, well, for domain expert, age and length are two different concepts. But for developers, they are just both numbers. So we want to stay in the domain-driven mindset, and we wrap all our primitives with a meaning, with concept, with something that you can relate to as domain expert. So continuing to derive entities from my first entity, I'm using the user wall, and that too uses a limit because you can only post to some amount of posts in our social network. And then again, I'm using wall limit as the type of limit. And it's basically a number, but I'm wrapping it with some sort of meaning. So now comes this special wall limit and age that I put on the side. They are fundamentally different than user wall or user profile. What is so different between them? Well, user wall, for example, have an identity. You can distinguish between two different user wall. They always carry some ID, and there is a meaning for a specific certain wall to be selected. But it's not the same thing with wall limit or age. Those are just a value object. And this is how we call it in domain-driven design. We call it value objects. So always distinguish between value objects and entities. Entities have an identity. That's the rule. Now, I can continue to derive entities, such, for example, the post entity, which is a part of the user wall. A user wall is a list of posts, and 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 this is what I do. And you can retrieve. And here too, you have age limit to each post, and we again use the object, the value object, which is called age. Now, here comes another tricky part of domain driven design. You have to you want to use the aggregate pattern in order to group some entities into a single unit, and you can treat that unit as one. Why that's important? That's important because you will always get those entities that cannot do not have a meaning outside the context of other entities. For example, user profile, it cannot just be a user profile by its own. It always goes through some context of a user. And there is no meaning to talk about the user profile without talking about the user that behind it. So user profile and your user wall and wall limit and age are all parts of the user aggregate. That's what we call it. That's how we say it. And there is a difference between user and user profile because user is the key entity, is the entity that all those entities refer to. So we would mark user as the aggregate root because user is actually the root of this tree. Just think about this aggregate as a tree and about the user as the root of this tree. Now, the user is a very special entity here because it's the keeper of this aggregate. No external code in the domain model or outside in the application layer can communicate or change any internal entity inside the aggregate except with the user entity. So the aggregate root is your key, is your gateway to a certain aggregate. And it should have all the methods and properties that allow external code to mitigate with this aggregate. Um, just keep in mind that this is all part of object-oriented design. So we want to keep the encapsulation in a proper way. Now, another aggregate that I have here is the post aggregate. The aggregate root is the post, and it's perfectly fine that I have only one entity in my aggregate. Um, now another tricky part, and it's a question that comes a lot. Why have I chosen to separate the post entity from the user entity? Why not just adding post to the user aggregate exactly as I did for user wall and user profile? Now, the answer to that is more complicated than you think. It's really about your design and about how you sees your design. It would be perfectly fine to see the post entity as part of the user aggregate, and then you will have only one aggregate, but that will have its limitations. So you really need to understand how your system functions in the domain that you're working on in order to get the correct domain model. So here I've chosen to treat posts as a self-existing entity. I want to be able to talk about posts in my application without referring to the context of a user. This is why I'm separating the idea of post from the idea of users. This is why I have two separated aggregates. So maybe a thumbs rule would be think about the queries that you want to support, think about how your system um, um, sees the domain that you're working on, and then conclude what you have to conclude, because um, those decisions have a long-term impact on your system and on your code. um, so I think that it's worth the time to spend on research and thinking about the domain model before we jump into coding. So I can label each entity with the right label. I have child entities. They are child entities of the user entity, and I have value object. Keep this segregation between value objects and child entity because it's very important for the implementation. And also keep the value objects immutable. it's very important for performance and the simplicity of your code in later stages. So that was a tough one. Let's see if there are any questions about that. Um, so the JVH asks if the aggregates provides the public interface. Now that's correct. Yes, the aggregates provide the public interface from which you can control the entire aggregate. You should never use external code to go into some internal entity in your aggregate. You should always use the root of the tree, the aggregate root. Cedric says that an aggregate is a tree of objects that defines boundaries in terms of consistency and transaction. This is completely true because once you have defined your aggregate, then you can ensure transactional consistency within this aggregate. So the aggregate root keeps your other parts of the other part of the aggregate consistent with each other. Thank you. Isn't the cardinality of relations between user and post that make my decision that post is an aggregate? User have many posts. Well, that's a tricky question because, well, the relationship between user and post is definitely one of your considerations to design your domain model. You should always think about those relationships. But the fact that the user have many posts doesn't imply that it should be segregated, right? You could always use the post as a child entity inside the user aggregate and just use a list to store all the posts. So it's not really about that, but I would say think about how your system sees a post. In a social network, you would see that posts have self-existing for in some social networks, you will see that posts have a self-existing meaning. They do not have to be attached to specific users. Users that wrote those posts are a secondary degree, have a secondary degree of importance for this post. Is it possible to implement domain-driven design in an OSQL database? Yes, there is no obligation or connection between the technology of the database that you choose to whether you use domain-driven design. It is definitely possible, if you think about it, to use other document-based database to support your domain to support your domain model. It's up to you to select the technology that suits your needs. And I think it's very interesting to think how we can model stuff like a complicated domain with different technologies such as graph databases or something even more crazier. But that's maybe for later. Okay, I will have to continue. Okay, we have our domain model figured out, hopefully. And now we can talk about the CQRS flow. So we want to approach the implementation. We already have in mind our domain model. We know that we are going to use CQRS, and let's see how the flows goes. So it all starts with a command. So you command express some intention to change the state of the system. Each command is picked up by its associated command handler. So for each command, just create the corresponding command handler. Now, command handler, I think it's the heart of your right model, because it does so many things. Basically, does everything that the right model should do. So I'm going to split all the what command handler does into four things. The first thing that the command handler does is to create or retrieve the aggregate's current state. So one golden rule, I would say, is to create a repository for each aggregate that you have. You can already see how my decisions in the step of deciding about the domain is already deriving my implementation. So here I'm using two different repositories, one for user and one for post, because I have two aggregates. And those repositories basically encapsulate my database. So I want to communicate with repositories. I don't want to communicate directly with the database. Um, and what the first thing that we want to do is to fetch the aggregate that is in the most accurate terms, we want to fetch the domain object that represents the current state of the aggregate. That's what we want to do here. So we fetch from we are using the user repository. This is the second line, to get the user that published this post, to retrieve its current state from the database. So the publisher here is just a structure that defines our user. Now we use post, which is a class that defines the post aggregate. We use it to create a new representation of a post. Now the command handler have two structures, each define an object model or the current state of that object model. And we use the information that we store in the command to know what to fetch and what to do here. Now, once we obtained those structures, we can execute actions on those aggregates. Now, this is a very important part, because here your domain model starts to actually do something. So the idea is to encapsulate all the logic and the business rules that the domain have inside those domain objects, and then you let them interact with each other to see if you can do stuff or if you cannot do stuff. This is exactly where you impose your business rules within the boundaries of the domain. So I would expect this publish post, which is basically stating the fact that this specific publisher wishes to publish that specific post. So if this publisher cannot publish this post from any reason that is behind our domain, then I would expect this a line to throw an error. This is how you impose those business rules. Now, if everything is okay and this line is legal, then you would just continue as normal, keeping in mind that your publisher object has just changed because you just published a post. So I would say that I like domain-driven design because I can retrieve the current state of my pieces in the Lego and then try to interact between them. And if this interaction does not work, then the command handler just reject the command because it's not legal to do. Otherwise, you can continue as usual. So this is a very important line. The third step that the command handler does is to write back the new state of the application into the database. So I'm using both of my repositories. Each has his responsibility to update my write database, and this is where the state of the application gets changed. So this is where you write stuff into your application. So my post object, which represents an aggregate represents a post, is being registered in the database, and the publisher, which I have changed in the second step, now gets written back, replacing the old value. So now that we change the state of the application, it won't be so meaningful if we won't propagate this change to the rest of the system, to the read model, because we want our users to be aware of the change that we just did. So everything that we are going to do from now on relates to the read model. So the last thing that the command handler does is returning an event that describes the change that has happened in the state of the application, and then finishes. So I'm returning a new post-published event that holds all the information about the change that I just did. And you need to keep your events as minimal as possible. You should only describe certain things that happened in the state, but nothing else. You should also try to, or I think that's very important, not to send with your events a domain object. I wouldn't send the post object or the publisher object to the rest of the application. Those are domain objects, and they should be locked inside the command handler. So those domain objects will only be in the domain model and in the command handler, but they would never exceed those boundaries, because you don't want domain logic to be exposed to any other components of your system. So now that we have propagated this event to the read side of the application, each event is picked up by its own event handler. So again, we have a symmetry with commands. Each event has its own event handler. And what the event handler does is basically project the change in state to the read databases. So now we have my two read databases. One is Elasticsearch and one is Neo4j, and I project this change onto them. So the event handler have to fetch the database that involves this event and then update it. So in this case, imagine that the event is that two users became friends. Then the event handler picks up the social graph repository, which is probably the Neo4j database, and set two users as friends. The Elasticsearch engine doesn't care about such a change in state. Therefore, we won't even update it during this projection. So this is called projection, and those read database, we often call them denormalized databases or denormalized data stores. Why denormalized? Because the normal, we consider the normal form of the data as the write database. So the read database are not a normal form of the data. They are just denormalized form that help us achieve a scalable querying. So once my read database is all updated, I'm free to answer queries about the stuff that happened. So query handlers have, each query should have its own query handler, exactly like commands and events. And each query handler fetches the corresponding or the associated repository, which in turn goes to the correct read database and receiving the information that it needs to receive. So that's the entire process. And consider, well, starting from sending the command until the point that you have completely synchronized your read databases, that's the inconsistency window. That's the time where your system processes this change in state and cannot be consistent with users that ask about this change. So this is the entire CQRS flow, uh, and, and we use the domain driven design principles to model our our write database. Yeah. So once we concluded that, I'm checking the time and our comments, and it's already 1. Okay. Um, yeah. Okay. I have to continue because I think we have only half an hour. Um, so if you have any questions, we can give it 2 or 3 minutes. Yeah, this is a very important comment here. Thank you. What we saw right now is using event-driven architecture. So we use events to propagate the change into our read models, but that's in no way event sourcing. Event sourcing will come afterward. So please distinguish between event-driven architecture, like you see here, to event sourcing. The reason I'm using event is because it's much easier to reflect or to project changes using events. It's just more natural. But you could always think about some complicated or different way to project the change into your read databases. I won't recommend it, but you can always use different ways to do that. So thank you for this comment, Adema. Could the read databases be collections in a document-driven database? Definitely. Definitely, your read database can be a Mongo database or any kind of basically any kind of technology that you choose to use. You just need to optimize this technology for your queries that you want to answer on. Well, I have to continue, and the next part is event sourcing. But maybe before talking about event sourcing, I want to show you some code, some actual code. Um, if you cannot see the code, then please say something in the chat. So I will just show you the way I wrote it, the domain. Let's just take a look on the user aggregate. So the user aggregate is basically, well, it's important to say that we are using JavaScript here, and we are also using TypeScript, which I think is great for domain-driven development. I think that TypeScript gives you exactly the stuff that you need, like interfaces and types, to have a more domain-driven code. So keep in mind that it's a very important tool to use when you're using JavaScript. Now, my user class is an extension of aggregate root, which is nothing to worry about. It's just another class that has some basic functionality, but nothing important. And it has its own fields. The most important thing to notice here that, for example, in order to implement the share post method, given a specific post, I'm imposing some business rules and then only then publish the post into the wall. So this is where I impose the business rules. And if something is wrong here, then I'm throwing an exception. And this is what we always call the domain object. Now, one important thing to notice here that usually one big mistake is to push to your object model validations, technical validations, such as empty arrays or empty strings, or checking for undefined or nulls. And that's, in essence, is the wrong way to go, because you want to keep your technical validations outside of the domain model. You want to keep them in application layer, maybe to do them in the command handler, but never check technical stuff inside your domain object. Just think that if you were a domain expert and you had no idea about coding, you could still understand some of the code that is written in the domain model. So any other type of validations or field validations, like checking if strings are empty or not, that should be done outside of your domain object. Now, that was the user aggregate, and the command handler is, as I promised, split it into only 4 steps. You create or retrieve your domain objects from the repositories, and then you apply your actions on those Lego parts to see if they match each other or not. And if they do, then you publish the change to the same repositories that you used to retrieve those changes. Now you have updated the state of the application, and the last thing you should do is to project this change outside using an event. So commands are nothing more than just structures that hold the information. They should never hold a domain object or anything that involves domain or any behavior at all. Commands, events, and queries should be simply small structures that hold the minimal information that describe intention or something that happened. Please also notice the naming here. Commands are always named something like create post command. So it's a command and we express the intention to do something in the system. Whereas events are always called something like post published event. So they describe something that has already happened in the system. They describe a change in state. And that's an important, very important to distinguish. Okay. Any question? Thank you very much, JVH. I'm very happy to hear that. The example will be available on GitHub. I will do my best. I immediately want to rewrite my code. Well, that's great. Just please keep in mind that CQRS and adds significant complexity to your code base, and you should approach it only when you absolutely need to. So that's a warning that you will see everywhere, and I agree. But domain-driven design principle, from the other hand, are very important, and I think they, at least some part of them, should be implemented everywhere. Alexander asks, I see you are using a lot of classes for commands. Couldn't we use functions? Well, functional programming, domain-driven design usually goes hand by hand with object-oriented design, object-oriented mindset. But I can think about a way to model domain-driven design using functions. But that's a completely another topic, and it has some problems within it because it's more like a procedural kind of programming, and that's fundamentally different. But that's something that we need to think about more. That's great, Cedric. That's true. It's not CQRS is not a high-level architecture pattern, and you only need, as I said in the beginning of this lecture, you should always choose wisely where to use it and for which features, and keep in mind the eventual consistency issues. And yes, I believe that Greg Young marked or coined this term of CQRS, although CQR was already there, and it's an older concept. Great. Now, let's talk about event sourcing if we have the time, and I hope we do. Yeah, we have the time. So, still, CQRS and domain-driven design, everything sounds perfect. So, why are we still here? Um, well, sometimes you need to answer queries that are even more difficult to answer, and even using CQRS and domain-driven design will not save you from making your system even better. Because with CQRS, you can see those two main problems that you cannot ignore. The easiest problem is that the state can be hard to compute. So remember that we took from our repositories the current state of the application, and we, as I say, try to match those parts of Legos one into the another, hoping that everything will go through, and then we save it back into the repository. But imagine that you have to do to imagine that this process can be very complicated and take a lot of time. So fetching data, making a huge computation in your command handler to recalculate the state, and then keep the state again, updating the state in the right repository can take a significant amount of time, and we want to minimize that as much as possible. But the second most, a more deeper problem that we have with this kind of domain, with this kind of design, sorry, is that we are always rewriting the current state. Um, so we can never know anything about the historical perspective of our domain. We can never understand, if we look at the data, we can never know how we got to this specific state in the application. We only know that we are in this specific state. So especially if you want to extract intent or purpose or reason in your data, then it would be impossible, because you don't have a lot of information. You just rewrote the state all over again every time you had some change in the state. So in some way, the pattern that I showed is a big loss of, is a way to lose your a lot of data, or a lot of important data. Now you could say that no, my system doesn't need that, and my queries are anyway limited to the current state. But actually, experience shows that you can never know on which queries you would have to answer in the near future. Your product owner can wake up someday and say, well, we want to think about the relationship between events that happen. Maybe users tend to do action A always after they do action B. And you want to connect your data store into some data analysis platforms that can achieve certain insights. Maybe you want to use machine learning, or any kind of artificial intelligent algorithms to get conclusions from your data. So we have a problem here. Now, the way to avoid this problem is to do something completely else, and it's kind of surprising at first when you just get this introduction. Instead of keeping this current state, instead of keeping those representations of aggregates in your data structure, you could always just save the events, right? Because we already use events to propagate the change to different parts of the system. So why not just keeping the events as they happen, one by one, in some event queue? You can completely replace any kind of database with the event queue and just keep the events in it. Now, if you think about it in a mathematical level, the series of events is all the information that you could ever get about your system. There is no redundant information here because it's the exact way of how things happen, and there is no missing information here. We are not losing even a bit of data because because your system is basically defined by stuff that happened in the world and arrived to the command handler. So keeping only the events in the event queue is safe, and it also makes your write model very fast and efficient. If your event queue is an append only data store, then you cannot delete events because you cannot change the past, and it's very fast to push a new event into the event queue. This is why we emphasize the word queue. Now, to the command handler, of course, need to, as we said in the first step, need to create or reproduce the current state of the aggregate. And that can be done if you just replay the events starting from the first event to some point in time. So just think about uh, iterating through all the event that you kept about some the changes that happened to some user, and then at the end you will get the current user. You don't have to store that structure. You can always just replay the events to retrieve it back, and then you can do those calculations on this event in the command handler. And and when you instead of just using events to propagate them into the read model, you could keep the event in the event queue and use the event to propagate the change farther down the line. So this is why a lot of event queues, the more sophisticated event queues, are also acts as a messaging bus. So they not only preserve the event that you send them, they only propagate that to the projector. So um, we can summarize it by saying that with event sourcing, we're simply storing the event themselves instead of storing the computed state. If you think about it, that's exactly what your bank is doing when it needs to maintain your bank account, right? Whenever you deposit money or take money, then they just add the event to the list of the events, and eventually, when you ask about your current balance, they just calculate it using those events. It's also making your platform to be a time machine, basically, because giving a specific moment in time, you could always replay the events to that specific moment and see the state that was before. That's a huge power, and that's also very helpful when you try to debug your system. So the event queue is the single source of truth of the system, and the state of the system at any point in time can be computed by replying the events. Now, of course, that immediately you get these reactions of wait, replying the events can be very slow, and you might have millions of events, and that makes performance even worse. But there you have another solutions like snapshots, where you keep a snapshot per some length of the event queue, and then you can recreate your state faster. But that's more advanced, and this is maybe for another presentation. So to summarize, the event sourcing idea is that nothing is changed in the read model, and actually there is not a lot changes also in the write model. The command handler recreates the domain state by replying the events, sending the aggregate current state to the command handler. Writes becomes much faster, and the event queue often acts messages bus, which propagates the event farther down the line. Now, event can be replayed at any point in time to recreate your read database. So if you want to reboot the system, if you want to completely remove the read database because there was some malfunction uh, or something like that, you shouldn't be worried at all, because you can always replay the events and restructure your read database all over again. So why event sourcing is helpful for domain driven design? Because with event sourcing, events are modeled as first class objects rather than through some implicit state changes, which makes the model closely resemble the actual processes they represent. So I see the event sourcing as another step toward domain driven design, because CQRS helps you have allows you to have a more domain-driven code, but event sourcing allows you to have a more domain-driven data. So, in some sense, event sourcing takes the behavioral context of the system to the data layer, which is the deepest layer that you can take behavioral context to. So I think that with event sourcing, your domain-driven implementation is complete. And I think that summarizes this session. Um, of course, that if there will be any demand, I would love to show you some event sourcing code in the next presentation. I see here a lot of questions and nice bookmarks from Cedric, and I'm really recommend to read all the material from the Microsoft archive, which is great. Um, um, yeah, there are people that already used CQRS and event sourcing here. Um, uh, Yeah, and there is one question here. We built warehouse management systems, and it feels to me CQRS and event sourcing is a natural fit. And that's a great feeling, and it makes sense that if you're I think that warehouse management system is a classical example of a domain-driven platform, and you should definitely consider such patterns, especially because warehouse management is the most natural way to think about warehouse management is the processes and events that happens during time in your warehouse, and um, that's a very good scenario to think to use those patterns with. Any more questions? Team writes that I want to use it with a projector to write the new total stock to a separate database. Yes, that makes sense. Your projector will allow you to spread the information, the change that happened to the state, to very different sorts of and kinds of database. And CQRS gives you the freedom to manipulate this change the way you want it to be manipulated. And I think that's a great power that CQRS gives you. Um, Wallace asks to do the next talk about event sourcing. I would love to. And I will tell the guys that we should do that. We should definitely do that. Can we see more of your Node.js code? Yes, definitely. I think that we have 5 minutes to go. So over time. So event sourcing, production requirements change over time. So event sourcing is great, and this is a great point, Adema, because you could always get new queries to support, and you could never know what to expect in this ever-changing industry. So you want to keep the most information you could about your users, and event sourcing allows you to extract a meaning in you from your data, because it's easier to understand what happened if you look on series of events. It's much more natural for us as humans. um, oh wow, that's a question. Is React also a form of CQRS? So if there are front enders here, then I wouldn't say that React has anything to do with CQRS specifically, but I would say that Redux, which is a React library, has a strong relation to CQRS, because Redux is about separating between queries and commands, and changing your state according to commands. So yeah, that's what you meant. That the Redux has, I think that Redux CQRS influence the developers of Redux a lot, um, because it makes your app to act like a state machine, which is very resembles to what we just saw. Yeah. Now, if we have 3 minutes, I will show you more of my code. So as we said, usually in the standard CQRS domain-driven project, you would see this kind of structure. So you have commands and then command handlers. You have events and then event handlers, and queries and query handlers. So there is a symmetry here. Commands are just very simple structures, and command handlers goes through those steps. So if I want to handle an event and command that asks me to share a specific post, I retrieve the aggregate state from the repositories. In this case, I have to use the both of the repositories, because both the user and the post already exist in the system. If they do not exist, I throw an exception. Otherwise, I impose those business rules. User should be able to share this specific post. If it doesn't, then there is an error thrown out, and then the command handler just ignore the command. And if we dive into this user share post method, that I see that here I'm imposing those business rules. Otherwise, I'm throwing the corresponding command. And if not, I'm just updating the wall. And back to the command handler. Once I have finished with, oh, no, that's the command handler. Now, when I finished with imposing those business rules, I'm updating the user repository with the appropriate object, and then sending the event back to some place in the system, which is the read model, to project this change. So thank you, everyone, and the recording will be available on YouTube as soon as possible. Thank you for your enthusiasm, and I really loved being here in Amsterdam with a great team of HackerJS, and I really want to see you again. Um, so good luck, and keep it safe in those crazy times. Uh, Goodbye.